Question for you all. I was just talking to someone in the hallway. So, you know those big intro, like economics classes? There's a raging debate at the moment whether to give the final during the finals period or during the last class period. So like, hands up if you prefer last class period, and hands up if you prefer the final exam period. Okay, very interesting. I've always been in the boat of like, let's have one more day of class where you can do like one extra thing. So this is very interesting. All right, how are y'all doing? Yeah, nice. Love to hear it. So this is from, let's see, yesterday we went to the library. It was a cold day. Look at this cute, pudgy little face. Absolutely adorable. Are you going to be sad to see Maxine gone from your life next semester? Okay, well, you can always like re-tune into the live streams. Yeah, like and subscribe. Okay, so we have a somewhat big one today. By the end of class, you're going to have an estimate for the gender wage gap, and we're going to do this in 4 different ways. And in the process, we're going to develop essentially 2 new techniques, extensions of the general linear model, into multivariate. So what we're going to start with is the very simplest version. But essentially what we're doing today is introducing what we call categorical controls. How many of you have heard of a fixed effect? Nice. And if you've read any econ papers, you've probably seen a fixed effect. It's one of the most common uses of the general linear model, or regression. And then the second thing we're going to do is introduce interactions. So we're going to introduce interactions to give us a sort of a different and maybe better estimate of the gender wage gap. I showed you a picture of Maxine. I'm very interested in her future. So to me, this feels like a relevant topic. If this feels relevant to you, you're in good company. So what we're doing is essentially estimating the differences in income by gender. So all of the models we're going to build off of this. I just want to show you a couple of pictures before we get started. Do y'all still like nice figures? Have I given you too many this semester? No is the correct answer. So the questions we're going to answer, or at least start to answer, essentially, like, can we go to the data and test whether there's a difference in income between male and female as it's coded in the census records? So we're going to use the definition that's in the census records for this question. So then the second kind of question we're going to ask is whether there's returns to education that are different by these 2 groups. And that's going to be a similar but slightly different question, which is going to give us maybe a nuanced picture of where the gender wage gap is coming from, and maybe some of the related variables. Okay. Any questions here? And today, so the rest of the semester, essentially, we're going to be focusing on, like, we have all the tools, essentially, in our tool belt, all the major ones, and you all are putting together final projects. So class time is going to, like, we're going to introduce new ideas each class period, but a lot of what we're doing, like the actual, like, doing of the class, will center on, like, putting together good projects. So I'm going to show you my process for how I get started with this, if this is a project that I was working on for the final project. So we're going to work with the data set. We're going to create a new notebook and then use that for our essentially an in-class project. And then hopefully there'll be some time at the end for you to chat with each other about your final projects. Okay, so the basic and sort of simplest general linear model we could set up to test for the presence of a gender wage gap. We can do this using tools we've already developed. Anyone have an idea of how we could set up a statistical test for a gender wage gap? Actually, I want you to turn to someone next to you, tell them how you would set up this test for the gender wage gap. And maybe I'll show you the data set before we do this. So I have in exercise 5.1 a link to a data set, census records. If we download that, I have this pretty extensive data set coming directly from the Census Bureau. Or it's coming through IPUMS, but from the Census Bureau. And a couple things you can see here. So we have all of these complicated looking variables over here. But here we have a sex variable, we have age, we have education, and then we have income total, and then income log 10. So looking at this data set, I want you to turn to someone next to you and maybe propose a statistical test to test whether there's a difference in income between the two groups. And maybe tell your neighbor something fun you did and how excited you are for Thanksgiving.
Oh, is it still?
All right, I've heard a couple people set this up correctly. Can someone help me out? What's going to be our test here? What's the outcome variable? What's the predictor variable? Sabi?
The outcome variable would be the income.
Okay.
And the predictor variable would be the gender or the sex, which is 0, 1.
Okay. So this is information given to us directly from the census. So what Sabi's saying is we're going to use income or income log 10 as the outcome variable, so the thing we're trying to predict. And then we're going to use sex as our predictor variable. This is information that's given to us from the census records. This is how the census codes it. Gender isn't binary, but this is the data that we're given. So this is how we're going to work with the data. So this will be our predictor variable, and this is our outcome variable. Anyone do this differently? So nice. We're using a binary predictor variable to predict income. You can go through and look that the way this is coded is 0 and 1. Okay. This is the setup, and I have some nice pictures, as you might expect. Any questions about this? I asked you questions about this on the mini exam, which will be back to you sometime soon. But this is generally a picture. So the vertical axis, I've left out the axis labels. This is fake data. We're actually going to use real data in a second. We're going to use the data set that I've given you, but this is just a pretty picture of the kind of statistical model we would build here. So we have, two different vertical intercepts. Here we have like our beta 0, so the intercept term, and then we have the slope term, which in this case I've drawn it as a second line, as you'll see in a second. So this is like the average of the second group, and the difference between the two averages is our beta 1. And you answered lots of questions about this on the mini exam. So here we're just testing for whether there's differences by group. You all want to actually test this? That's not the rousing enthusiasm I'm looking for. This is an amazing research question. It's been asked over and over again, and what we have is actually a data set measuring the real world where we can go out and directly test the presence of this thing. Can I ask this again? Are you ready to actually test this?
Yes.
Thank you. Okay, that's better. So the way we're going to do this, you can turn to exercise 5.1 and click on the notebook. But different than normal, when you open this, I want you to save it. For a lot of you, you've been saving the exercises as we've been going through. When you open this, you can go up to the top and hit save. Save a copy and drive, and that will put it in your Colab folder. I think I've maybe mentioned this before, but you have a Colab folder here. And what I did is create a folder called Part 5. This is very similar to what you'll do for your final project. So I recommend you follow along with this. So I created a folder called Part 5, and I have, well, we'll talk about that in a second. So, so when I open this this notebook and hit save a copy and drive, that should put a copy directly in my Colab folder, and it'll say copy of. So what I do is I just go in and rename it. So I'm going to say exercise 5. Okay, any questions here? I'm going to show you how to use this. I didn't give you a link to actually load the data set from my website. And this is on purpose. I want you to have some experience loading notebooks or loading data sets in notebooks in your own Google Drive. This is how you'll do it for your final project. Okay, so let me actually delete this from the folder. But you can see I have exercise 5, and then I have a Part 5 folder. Part 5 is where I'm going to put the data set. So if you go to the exercise card here, you can click on the census records link, and this will download a CSV file for you. So you've gone out and collected a bunch of data from some website. For me, I got this from iPooms. I've shown an example of iPooms before, but it just houses a lot of great data sets. And this is the one, this is how I downloaded this data. I just went in and clicked on Get Data, and then you just go through and select which samples you want, and then you can collect different variables from each of these lists. And this is just coming directly from the government. This is like very nice data sets going all the way back to like the 1800s and as current as like last year or 2003 or 2013. Nope, 2023. Okay, so if you're interested in this kind of data, the census records through iPooms is a great place. It's a little bit advanced, so if that looks overwhelming, no worries. But the main point here is I have a nice data set that I just downloaded, and I'm going to put it in my Google Drive. So I'm going to drag this over, drop it into my Google Drive folder, and then you can see I have USA sample data.csv. So if I open this, so I open the one that I have in my folder, it shows me a bunch of things. The first one, I'm just going to import everything and then mount my Google Drive. How many of you were able to get to this step? Hands up. And how many of you are, if you're struggling with this step, feel free to reach out to someone next to you or like ask me a question about what's slowing you down. So what this is doing is Google Drive, excuse me, is asking for us to log in. So we're in a notebook, but we haven't yet given the notebook permission to access our Google Drive account. And that's what we're going to do next. So I have this mount to drive code here. This is just allowing the notebook to connect to the Google Drive. And then this is just my personal Gmail account. Don't spam me. So now we're just letting the notebook log into Google Drive. And what I've done here, I've given you some code just to locate the file, the folder that the data set is in. It's called part 5. And then we're just going to that, we're sort of like moving around in the file system to that folder. So this is just a bit of code to let you do that really easily. And then all we have to do is load the data. So if I run this, it's going to look in that folder. It's going to look in this folder, sorry, the part 5 folder for this data set, and then load that. So in the past, I've given you a link on my personal website for you to load from. This gives you the ability to load your own data sets, which is one of those skills. It's not that interesting, but it sort of lets you set up your own work. Any questions here? About as interesting as data cleaning, right? This lets us get to very interesting questions. All right, so we've set up our data. I've coded a new variable, which I'm calling mail. You could code this however you like, but I think in this case, we generally would expect there to be a gender wage gap. So I'm going to code this as 1 for male and 0 for female. And this gives us a little bit more information, a little clearer of a variable. And then I'm just going to print it out. So then for the first statistical test, we're going to run this thing. So our very basic general linear model. We're predicting wage using, or income, using beta 0 plus beta 1 times male. And then, so in this case, you've told me you know these things. So this is a bit of review. Beta 0 is just the average income for female, so for 0 in our male group. And then beta 1 represents the additional income for those who are coded as 1 in the male column. So that would be evidence of a gender wage gap. This binary variable is often what we call a fixed effect. And this is just some code to be able to do it. So I'm going to copy this over. So we have our outcome variable is income log 10, and then we have our single predictor variable, which, as you've seen in the past, this is identical to a 2-sample t-test. So we're just going to run this, and you're going to tell the person next to you whether this tells you there's a difference in incomes, male and female. So this is, you're going to interpret these coefficients and tell your neighbor what you're seeing. And if you have questions, raise your hand and I'll come around and give some guidance. Yeah, we'll take a couple minutes here.
Coefficient for the intercept 4.4040. That's going to be what that means. We'll say that 4.4 whatever is the basic cost of the intercept is significant because the p-value is 0. The slope is significant because the corresponding p-value is 0. So it increases from the base value of 4.4 by this much when someone is a male. So what's the issue with you?
I call it part 5. That's where it puts it.
So yeah, and then I just drop the data set here too.
Sure. Okay. I have a quick question.
It won't.
Yeah, you have to also rename things because it won't let you do CS with
Okay, someone help me out here. Do we find evidence for a gender wage gap? Someone want to tell me why? Luke?
Yes, because p-value corresponding with the slope coefficient is significant. It's pretty much 0, which is less than the common significance level of 1.5.
Okay.
So, yes.
Okay, so yeah, a couple of things, right? The first one is the coefficient, and then Luke is pointing out that this is very unlikely to be coming from no gender wage gap. Like data like this is very unlikely to be coming from a no difference by male. And the interpretation here is that if you're male, you're making 0.16 log units of income higher. We'll spend a second interpreting this this log coefficient in a second, but essentially this is like roughly 15% of a 15% difference, which corresponds generally to what we see in the literature. Okay, any questions here? How many of you are still having data issues? Hands up. Okay, so if you're still having issues, nice. Okay, so I think the people around you will be very helpful with resolving your issues. I can swing around and be helpful as needed. Okay, so this is very interesting. So we've actually gone in and tested, just looking at the census, whether those coded as male are making more than those coded as female. And we do see a very significant difference. This difference truly matters, and it's also very unlikely to be coming from no difference. Is this concerning? Yes, it should be. This is not the thing we're looking for. So just for an interpretation here, we found that beta 1 is greater than 0. This was the slope coefficient on male. And this is strong evidence for a difference by gender. Turns out there are many explanations for where this is coming from. One of them could be that there's some other variable that's correlated with both income and gender. So as an educator, I'm deeply interested in the following question. Whether other variables like education are correlated with both gender and income. So I'm going to present to you a second model, which looks like this. So vertical axis is wages. Unfortunately, there's no vertical axis labels. Who wrote these slides? Okay, that joke was funny twice. Now the third time it's not. You know my classic joke. I have a PhD in economics, not stand-up. Have I told you that one before? Okay, sorry. A few times, all right. So I proved my point, I guess.
Yeah.
Okay. So horizontal axis is years of education, and then vertical axis is our outcome variable wages, or income. And I have a model here. This is, again, this picture is not coming from the real data. This is coming from a simulation. But this is generally what we see. Years of education on the horizontal axis has a positive relationship with the outcome variable of income. I can't remember it because it's not listed on the slide. Okay. We can use this. So our classic model here is our x variable is years of education. We have beta 0 plus beta 1 times years of education predicting income as our y variable. But what if we broke this out by male 0, 1, or by gender. We could set up a model that looks like this. We have two subgroups in our data set, and we can color them different colors, which makes it easier to see which group is which. This is a really simplified picture of this. Obviously, it's not going to be this simple when we actually go to the census records. But this is a picture of two different groups. So the one group has data points that sit below the data points for the other group, and it's essentially like one group is shifted up. And I'm going to present to you a model for testing whether there are differences between these two groups after controlling for education. So this is what we call a two-intercept model. So we might expect that education is positively related to both groups' income. So income should be higher in both groups for those with more education. But maybe there's just a baseline difference in the two groups. Like baseline income would be different. I don't know if I said that very clearly. So the way we can test this is by including two different intercepts. One for those coded as 0, and one for those coded as 1. Which will essentially allow us to test whether there is a shift in the vertical dimension. Whether one group actually has higher income after controlling for education. Any questions about this model? Okay, so I'm going to ask you, before we test this model, to write down an equation that would do this thing. So you're going to take 2 minutes. You're going to try to write down an equation that would let you do this. And you're maybe not going to succeed, and that's all right. So take a wild guess, write down an equation, and then we're going to come back together and build this model together.
No, there you go. Related to be a dummy because it's going to be added into the model if it is not in the model. So, trying to remember what the notation for dummy variable. Is that the right idea?
Yeah.
Okay. Let's just I think you can do Z.
It could be even simpler than that.
Okay.
I've actually already given you a dummy variable.
Oh.
And actually, we don't use dummy variable as a term anymore. It was in my slides from last semester, so it's like a recent cut.
Gotcha. I need to catch up with the times, I guess.
Here we are, catching up.
So, yeah, I was curious to see. Okay. That.
Okay, someone want to help me out here? What's an equation we would write down to test this model? Whether the two lines are different, have different intercepts. Anyone? Actually, I'm looking for wrong answers only. Someone give me a wrong answer. Sabi.
The GLM equation. Okay, so
Okay.
y is equals to beta 0 plus beta 1 of x1 plus beta 2 of x2 plus error.
So actually, that turns out to be the right form, just we need to define what x1 and x2 are. So Sabi was saying y, our outcome variable, in this case being income, is equal to beta 0, our intercept term, our generic intercept term, plus beta 1 times an x1 plus beta 2 times an x2. So now we've added another variable. Someone tell me what those two variables are, x1 and x2. Now I'm looking for right answers. But you can get it wrong. Yeah, Jason.
Education and then male.
Education and male. So let's write this down and then we'll talk about what this means. How many of you wrote down something that resembles this? Hands up. Nice, not that few, or not that many. So a sufficiently difficult question. So let's just talk about what this means. Beta 0, this is our intercept term, which is just the generic intercept term for our 0 group. It's the intercept at 0. So this is 0. And then beta 1 is just the slope of either of these lines. So we're just including an equation that captures the relationship between either of the two lines. But then this last part, beta 2, captures a specific intercept on top of the original one for the group that's coded as 1. So it's like an additional extra for those coded as 1 in male. So we're essentially we're adding an extra, we're just essentially including another slope coefficient to this model. We're just treating the variables as possibly having a slope. Okay, Sabi?
I have a question about the variables that we use for the Gibson equation.
Yeah.
So for one of the variables, we're using male specifically, and I
Yeah.
just want to ask if it's okay if we use sex instead of just male, or if it's just.
Yeah, so you could use sex, which is the variable that's coded in the census records. You could just use that directly because I think it's calling it sex is less informative than calling it male, which is why I use male. You could also call it female. You just flip 0 and 1. So we call these indicator variables, which just indicate yes or no. Which is why I'm calling it male. But you could equally call it female, and then you just subtract 1. Okay, any questions here? So just like in our original model, we have 2 separate intercepts. One for the 0 group and one for the 1 group. What's different here is we're adding a horizontal axis of education. So in addition to finding 2 different intercepts for the 2 different groups, like we did in our baseline model, now we're just allowing them to have a slope. But the slope is the same for both groups. So, so this isn't conditioned on whether you're in one group or the other. Any questions here? So when you're thinking through these models, I want you to think in these terms. Set up a scatter plot or the appropriate visualization. And then if you're checking differences between groups, you can just give them 2 different colors, and then you draw your lines, and you build the model from there. This is how I think about these problems. I start with a visualization, like we did in part 1. I then draw some lines, and then I build the statistical model on top of that. All right, so the interpretation here, beta 0 is the base wage for those with 0 education in the data set. Beta 2 is the gender wage gap after we've sort of controlled for education. And then we're enforcing that there's parallel lines. education is not conditioned on whether you're male or female. Okay, so that's the interpretation. The next step is to actually run this. So we'll take 2 minutes. I want you to actually run this model in the real world, and we're going to check whether after we control for education, does the gender wage gap persist. We'll take 2 minutes here. All right. Someone want to interpret this for me? What's going on here? Sabi?
So it says that the intercept is basically when we have female as the sex.
Okay.
The income is about 3.03 logs.
Okay.
And with an increase in education, the income increases by about 9%, 9.87%, and then
Okay.
when we shift to the sex as male, the income increases by 20%.
Okay.
20 point.
Yeah, so this is a great interpretation here. Everything is very unlikely to be driven by a null hypothesis, very inconsistent with the null. So the intercept here is just the number of log units. So we're 3 log units away from 0, which I guess this is household income. We'll come back to interpreting this. This is part of the problem with using log. Log is the correct usage for looking at income because of the scaling properties. But it does become more challenging to interpret what this means. So then, but we'll come back to this in a little bit. We're 3 log units away from, so it's like 10 to the 3 is the intercept. And then Sabi's saying, look, every additional year of education increases your income by roughly 10%. Is that right? Sorry, 1%. We're off by 1. Yeah, 1%. Every additional year of education increases your income by 1%, which is a lot. That's massive. And this compounds. I'm sorry, no, this is 10%. Yeah, we round up, so this will be 1, yeah, roughly 10%. Any questions here? Okay, so then for male, what do we see here? We definitely see that there's a difference that persists after we've controlled for education. So we've allowed for there to be an increase in your education, an increase in your income with education. And even still, we see differences on the vertical axis. One group is just shifted up. by some amount. Okay, any questions here? And it looks like after we control for education, the difference has actually grown. So the gender wage gap doesn't go away when we control for income. It actually becomes wider. Okay, let's try to reverse this. All right. Look, we have powerful tools that allow us to see things that have real impacts in society. This is how we understand these things. This is how we get at understanding of social problems like this. All right, so is this depressing? Or do you feel empowered? With the tools, like the tools to see these things.
I thought you meant because more than
No, we have the power to be able to see these things in our data. Like this is how we know. So great. So we have our second model. We're building a statistical model that looks like this. Two different intercepts. We've controlled for another variable, and this gives us the ability to check whether there's a gender wage gap after we've done some controlling. We're going to develop another model in part 5.2, which we call an interaction. So what if, in addition to having just different baseline incomes, what if there's actually a difference in the returns to education? So what if there was a gender wage gap that came from differences in educational outcomes? As an educator, this would concern me. So this is another question we can test. What if education, we know education benefits most people. What if it benefits genders differently? This is another thing we can test. So this is a picture. We're going to take 2 minutes, and this time you're going to write down another statistical model to maybe try to answer this question. We want two different slopes. We want a slope for the female group and a slope for the male group. And with this model, we're going to enforce that there's only one intercept. So same intercepts, but different slopes. We'll take 2 minutes. Throw out some wild answers. You may get it wrong, and I'll ask you for an incorrect answer in a second. The question is, same intercept, different slopes. How do we set up that model? Different returns to education. Okay, someone want to throw out an incorrect answer here? How would we set up this general linear model? Different slopes, same intercept. This is maybe the trickiest one so far. So we want a slope that captures specific, so we want the intercept, so it'll be a beta 0. We want the horizontal axis, we want to slope through all of the data. So we're going to have a beta 1 on education, but then we want some extra slope that corresponds with the non-zero group. So not just the baseline slope for the 0 group, but an additional slope for the 1 group. And in that case, the way we do that is by multiplying 2 variables together. This is what we call an interaction. So we have the baseline, so our intercept, our beta 0, which shows up here. We have our slope for all of the variables that are coded as 0. So all of the data in this male group that's coded as 0. So this is our beta 1 going through all of the data points coded as 0. And then we have this second more complicated piece here, which is beta 2, which is the additional slope for those coded as 1. So this is education times male, which gives us this extra difference in slope. So the slope of the green line is actually beta 1 plus beta 2. All right, any questions here? So how do we interpret this? Turn to someone, tell someone next to you how to interpret beta 2. Take maybe 2 minutes here. How do we interpret beta 2? You could say it in words. We don't have numbers yet. Yeah. Yeah, so if we took out beta 2, if we just like lopped off the back end of that equation, the beta 1 would go through all of the data. So right now it's just going through the blue line, or the blue data points section. But if we took off that extra bit, then it would go through the middle of all of the data, which would be the middle of both the green and blue. Yeah, that's a great question. Okay, someone want to interpret beta 2? Yeah.
The additional amount that a male would make for this same amount of education as a female.
Yeah, so it's essentially the extra returns to education for male. Yeah, great. I'm sorry, remind me of your name?
Kyle.
Kyle.
Yeah.
So Kyle is saying this is the extra returns to education for male. We haven't estimated this model yet, but that's what a beta 2 would tell us. I had a great question, which was, what happens if we just take all of this second piece out? Like, what if we delete this from the equation? Well, it turns out right now the beta 1 is just going through the 0 data. So those who don't have this additional returns to education for being male. If we take off this interaction term, that would make this beta 1 a line that would go through the middle. So just be our regular regression equation. So what we're doing by including this interaction term is sort of separating the two. We're separating the groups by including this interaction term, which does change the interpretation of our beta 1. The beta 1 would be interpreted differently with and without this interaction term. That was a great question. Any other questions here? Okay. So we're going to estimate this model. Beta 1, in this case, is returns to female education. or returns to education for those coded as female. Beta 2 is the additional, so it's the extra on top of the 0 group, the returns to education. The difference in slope between the two groups. And then the male education effect is the sum of the two. So essentially different wage paths. So all we're gonna do is copy this over. You can see I've coded in the regression equation. And we have this handy little tool here which allows us to multiply variables. So we have edu, which is our education variable in the data set. So that's edu, which is here. And then all I'm doing is essentially in the regression equation, multiplying the two variables together to create the interaction term. And that's with this colon. All right, so run this, interpret the coefficients, primarily the interaction coefficient, and tell your neighbor how you would interpret it. Like, what is this telling us about the model? Or what is the model results telling us about the world? All right, someone want to interpret this regression output. What is this telling us about the difference in returns to education by gender? Yeah. So we're seeing a difference in returns to education by gender. So we look at this interaction term. So we look at this this row. We see this coefficient, and then we see that this coefficient is very unlikely to be the result of a null hypothesis of no difference. So this looks very consistent with a difference. Should we be concerned here? This is a big difference. I think we should be concerned. Particularly as an educator, this concerns me. This is a difference in returns to education by gender. Any questions here? This is looking at the population. So this is at a population level. The data is taken from 2019, but it includes lots of ages. So this is not just people in school today, but also everyone who's alive in 2019. But yeah, I think this is a real social problem. Lots of reasons this could exist, and we'll examine one of them next class. The last one I'm gonna show you is what happens if we include different intercepts. So what if we allow both groups to have different intercept terms, and then also different slopes. So entirely separate regression equations through both of the data points, through both of the groups. So we interpret beta 2 in this case, if it's significant, is that there's high returns to education for male. And then we're essentially assuming that there's a baseline intercept that's the same for both groups. So we're enforcing that they both hit 0 at the same place, which may not necessarily be true. So the last thing we're going to do here in the next 2 minutes is actually test a model where we sort of combine both model 2 and model 3. different vertical intercepts and different slopes. And then the first class, when we get back from break, will be separating out, or like trying to identify which model is the best one. But this is the model we'll work with here at the end. This is the regression equation for it. Each of these parts you've already become familiar with. We have a baseline wage for those with no education, no years of education, which is a high school degree in our data set, is coded as 0. Beta 1 is our baseline returns to education. So this is the blue line. So if you're coded as 0 in our data set, beta 1 is the returns to education for you. Beta 2 is the additional vertical intercept. So it's for those coded as 1 in the data set. So it's the additional wage premium for those coded as 0. Sorry, those coded as 1. And then we have this interaction term, which gives us that extra slope on the slope, the line. So we have this extra slope beta 3, which gives us the slope for the group coded as 1. Okay, clunky way of saying this model. Any questions here? The point is that we're allowing different intercept terms and different slopes for the two groups. And here's the code. And then we can run this over to include our full model. Now, you're going to run this. You're going to tell your neighbor how to interpret this. What are the caveats? And then we'll come back and talk about this in a second. Maybe 2 minutes here.
So we then have to reduce it to just the intercept in education. This,
It's the base wage for those in the 0 group.
Like if we choose 0 as female.
Yeah.
Then the base wage for female.
Yes.
And then additional to
Okay. So as a last little thing before we sit down and chat about projects, someone want to interpret this, what the intercept is doing. What does this number tell us? Without needing to interpret the logs necessarily. Yeah, Savi.
So this tells us that if we choose 0, x equals to 0 as female, that would mean that the base wage for a female, without considering education, would be 3.07.
Nice. So this is the baseline income for those with a high school degree if you're coded as 0. And then someone interpret this coefficient, the coefficient on male. Yeah, Kyle.
Would it just be 11% higher than the female coefficient?
So yeah, so this is 0.1 log units higher on the vertical axis. So it's everyone who's coded as 1 in the data set, the additional income for those in that group. What about EDU? Someone want to interpret this one? Oh, we should make one caveat for the male group. So this is a very large p-value. So this indicates to us something about the model, that once we've included both the male intercept term and the interaction term on the slope, we've lost some significance on the on those coefficients. So something has changed as we've introduced both the two intercepts and the two slopes. Today, we're not going to arbitrate which model is best, which of these four. That's what we'll do when we get back from break. Someone wants to interpret this this coefficient. Someone other than Savi. Luke?
For every additional, like, what are we gonna say, like level of education, the log of income increases by approximately 10%.
Yeah, so the log increases by 0.1. Yeah. So every additional year of education, our income goes up by 0.1 log units. Okay, and this looks very significant. P-value is very small. And then what about this last one, this interaction? Savi is ready to give an answer. Once we're done with this, we'll sit down and chat about final projects. Like I'm saying, this is the last thing we're doing. Yes.
It's like the additional income gained by the males per year for each year of education.
So this is telling us the additional returns to education for those coded as 1 in our data set, male. Yeah, very nice. The last thing to notice here is that this is also, this could be due to chance under a null hypothesis. So it could be that the two groups are, do have the same returns to education. Because this is not very far from 0. So yeah, we have a lot going on here. Comparing particularly model 3 and model 4, we can see that including separate intercept terms actually captures maybe a lot of this difference in returns to education. We'll talk about how we arbitrate which model is better in 2 weeks. Any questions here? Okay, so I use this as I think, a pretty powerful example. These tools allow us to see social problems. Like, we can use these kinds of models to ask pretty important social questions, which gives us a lot of power to see things that are happening in the world. So we're going to spend the rest of class just sitting down and having a conversation about final projects. I want to have a conversation with basically everyone in this class over the next 2 weeks. The end of class, last 15 minutes of class, every class will be devoted to final projects. So if I haven't talked to you yet, I'd love to talk to you today. Office hours tomorrow are also a good time to sit down and chat. And then the first week of December, we're going to have a kind of like a final project workshop. So we're going to sit down and have some extra time for that. All right. Hopefully this feels powerful and gives you some extra tools for working on these kinds of things. Love to chat.